Now what we have seen is that if we talk about these groups, that is from 13 to 18, then the first member, that is the first member, that means the main member or you can say the leading member of the group, the first member of each group differ from its cogeners. Differ from its cogeners, that means differ from its rest of the members of the family. Then what is the reason? Like if we talk about the boron family, boron showed different characteristics as compared to its cogeners. Carbon shows different characteristics, nitrogen show different, oxygen show different. That means they behave in a different manner. They have some anomalous properties that are not you can say shown by the rest of the members. Now why the first member shows different properties as compared to its cogeners? Then the basic reason behind that is the difference in the size and the size related properties. As you know that each member, that means each first member I am talking about, then each first member has you can say more nuclear charge, right, due to which it is smallest in size. It is smallest in size, and being due to because it is smallest, so that means it is going to possess very high ionization energy, or you can say it is going to possess high ionization energy, and moreover due to small size, obviously its electronegativity is going to be more. So that means due to small size, due to high ionization energy and due to high electronegativity, it actually differ in many properties as compared to its cogeners. The second reason is that absence of d orbital, right. That means each member of the first family is lacking d orbital. It doesn't has the d orbital. Therefore, it affects the properties of the elements in many ways, like it cannot extend its coordination number beyond 4. It cannot extend its covalency beyond 4, because here the filling of Ns and Np will take place, and as we know that S has 1 orbital and P has 3 orbital. So that means only 4 orbital can participate in the bond formation. So therefore it cannot extend its coordination number, and due to the reason what we get to see is, like if we talk about here in the boron family, we see that boron exists like this, like if we talk about its halide or if we talk about its hydride, then its fluoride is typically of this formula, right. That means it can accommodate only 4 fluorines, but if we talk about aluminium, then it can accommodate 6 fluorines, right. And the reason being because it has d orbital, so therefore it can extend its coordination number beyond 4 also, but this cannot do because it doesn't have a d orbital, right. And that is the reason, like if we talk about in the 14 group, we see that carbon exists as only CCl4, but if we talk about silicon, then silicon exists also as SiF6 or SiCl6, so it can extend its coordination number, right. Likewise, if we talk about nitrogen family, then nitrogen exists as NF3 if we talk about its fluoride, and in the same member, the next member, that is the phosphorus, can accommodate actually 5 chlorines also. So that means this is mainly due to the absence of the d orbital. They cannot extend their coordination number beyond 4, but the members which have d orbital, they can extend actually, right. And the moreover the another property which is actually influenced due to absence of d orbital is that reactivity. There is a difference in the reactivity. The one which has a d orbital is comparatively more reactive as compared to the one which do not have a d orbital. So as we know that d orbital starts from this place, so that means they are more reactive, the lower members, as compared to the upper members or the first member which is lacking the d orbital, because d orbital is somehow you can say d orbital has more energy. More energy means it is unstable means it is more reactive in nature. But if we talk about the first members, they are not having any d orbital, so they are less reactive. So moving on to the third main reason behind the anomalous properties of the first element is that tendency to form multiple bonds. What we see that each member of the first member of the family can actually participate in the pi bond formation, right? So, but the type of pi bond it can form is the only p pi and the p pi, because it doesn't have d orbital. But if we talk about the members which are lower, which are having d and f orbitals, they can actually show d pi and p pi bonding also, and moreover they can show d pi and d pi bonding also, right? So that means they can show, you can say, more kind of bonds. Can be tendency to form multiple bonding is more in the case of the one which has d and f orbital as compared to the one which are having the p pi and the p pi bond. As we know that this kind of bond actually is unstable because it has higher energy, but though it is not you can say contributing in the stability, but still it is contributing in the coordination number, as they have the tendency to form multiple bonds, they have the vacant orbitals, so they can actually extend the coordination number also, So these are the three properties, the main three properties which make the first member different from its cogenus. That is the difference in the size, it is smallest, high ionization energy, high electronegativity, no d orbital, due to which it cannot extend its coordination number beyond 4, and it is comparatively less reactive, and tendency to form multiple bonding is, though it has, but the tendency is less, because it can only participate in p pi bonding, not in a d pi or p pi or d pi, because it is lacking d orbital.